Algebra 2, Section 2.2, Part 2. You might even consider this a Part 3 because there was the domain and range video worksheet combo that you should have done first before doing this. This is a beast of a section. That's why I've divided it up into 2 days. But I hope you're working hard at it and making sure that you're committing these things to long-term memory, these different forms of lines and knowing the slope formula. And there's going to be more today, more in this video. All right, so something called slope-intercept form. This is always kind of like home base for most students, right? Slope-intercept form is the one you learned first, and it's kind of the easiest one. So that's one of the reasons why I don't start out with it, but rather I taught you point-slope form. It's aptly named, just like point-slope form, because if you have a slope and a y-intercept, then you can write the equation in slope-intercept form. And you can see that it's y equals mx plus b, and I'm pointing at what the slope is, m, and what the y-intercept is, b. The reason that the b is the y-intercept, it's not that somebody just made that up or whatever, but think about it if you plugged 0 in for x. To find an intercept, you plug a 0 in to the other variable. So if I plug 0 in for x, you'd be left with just the y being equal to b. Okay, if that's a 5, if b is 5, then the y-intercept would be at 5 because when x is 0, y is 5. That's how that would work. Okay, and then the third form, there are 3 forms. Point-slope form was in the last video. Slope-intercept form is what I just talked about. The last one is called standard form. Capital AX plus capital BY plus equals capital C. The A, the B, and the C are capitalized. This is to remind you that they should be integers. Now, integers would have been talked about in section 1.1, which we have so far skipped. So let me just tell you quickly what integers are. It's actually listed there. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., and the negatives of those numbers, -1, -2, -3, throughout infinity, okay? So these need to be integers, which is to say that they cannot be fraction or decimal. They need to be integers. And to that form, we're going to do an example, a graphing example, that is. It says to graph 2x minus 3y equals 12. Now, what a lot of people will do, and I don't like this, I mean, I can't really stop you from doing it, but what I don't like you to do is to switch it over to slope-intercept form. That seems to be, again, kind of the home base. You're putting yourself at a disadvantage if you don't realize the way I'm going to teach this, what I think is the right way. But yes, you could still get the right line if you would do some manipulations on this and get y by itself and then graph the y-intercept and graph the slope. I'm aware that you can do that. I'm asking you not to. But rather, what you should do is plug 0 in for x and see what the y turns out to be. And then plug 0 in for y and see what it turns out to be. This is a better method. Okay, you're finding intercepts. And the way that we get around that too, you can't just ignore this method, because the way we would get around that is we would say, here's an equation, and then the answer blank on the test would say, give the x-intercept, and another answer blank would say, give the y-intercept, and then graph the function. So anyway, what would happen if I plug 0 in for x? You know that it's like this is now just gone, right? This is gone, and you're left with solving just -3y equals 12, okay? If I plug 0 in here, this is like gone, and you're solving -3y equals 12. Okay, so you would divide both sides by -3. 12 divided by -3 is -4. There's an intercept at 0, -4, the y-intercept. What happens if I plug 0 in for y? Well, now it's like this is gone, and you're left with just 2x equals 12. That would be 6. Divide both sides by 2, and that would be 6. So there's a point at 6, 0 on this line. Now, wasn't that easy? Nothing hard about that. And even if the points are close together, these are spaced out pretty well that you could probably draw a nice straight line that passes through them, use a straight edge. But if they're closer together, especially, what you want to do is kind of in a slope way figure out what that is. I'm going left 2, 3, 4, 5, 6, and down 4. Really, that's over 3 and down 2, over 3 and down 2, over 3 and down 2. That's left 3 and down 2. The slope of this is actually 2/3, rise over run, 2/3, 2/3, 2/3. And just to put a few more points out there before I go ahead and draw my line, you use a straight edge. Like I said in a previous video, it's great if you would draw nice long lines that span the graph, and if at all possible, show where they cross both axes. Okay, that's graphing out of standard form by finding intercepts. Okay, now let's look at an example. An example where we left off yesterday, because this says to write it in standard form. I keep saying yesterday because I made that video yesterday. 2-2 day 1, part 1. I write in standard form. We got this far. We stopped in point slope form, but now we want to make it look like ax plus by equals c. So to do that, you're going to distribute the 3. Just notice what's in the wrong place. Obviously, y is already in the right place because it's on the left side of the equation like this is supposed to be. This constant's in the wrong spot. The x is in the wrong spot. So we're going to get rid of parentheses by distributing. Then we'll go ahead and subtract 3x from both sides. And again, now the constant -5 is in the wrong spot, so we'll go ahead and add 5. And that would be in standard form. Okay. Notice that this number is -3. This number is 1. This number is 8. Those are all integers, so you are good to go with that. Incidentally, 3x minus y equals -8 for this year would also be considered standard form. I believe in pre-calc they do require you to have the lead coefficient to be a positive number here. So they will only accept this one. For this year, my students anyway, I'm going to accept both of these. Both of these work. All this is this equation that I multiplied through by -1. Just changed all the signs. These are both in standard form. One more thing about standard form. The answer document to the Prentice Hall stuff does allow for fractions. I don't know why. It's weird because the geometry stuff didn't last year, but now the Algebra 2 allows for it. So you're going to need to do some multiplying through or whatever. You are still required to have integers. This stuff rolled down from pre-calc. We need to have integers here. So if you got a 1/2 here, or 2/3 here, or 3/4 here, multiply through by the denominator. If there's more than one fraction of a different denominator, multiply through by the least common multiple to make those integers. Okay, now we're going to roll up to example 6. Find the slope of -7x plus 2y equals 8. Find the slope. Well, you know y equals mx plus b, slope-intercept form. You can pick the slope right out of that. So let's try to manipulate this to look like that. Basically, the key characteristic is to get y by itself. So as I say often in class, ask yourself what's happening to the variable and then undo things in reverse order if you're trying to solve for it. So y is being multiplied by 2, and then it's being added to this -7x. So we'll add 7x. And I put it here rather than saying 8 plus 7x because I know what slope-intercept form looks like, and I just want to make it look like that. And then you would divide by 2. Now look, when you divide by 2, you would divide everything by 2. Each term gets divided by 2. Y equals 7/2x is how I like to say that. Not 7x/2, but to put that out front, it really kind of isolates the m a little better. And then 8/2 is 4. This is your slope right here. You want the slope? It's 7/2. Okay. Back to this document here. Parallel lines have the same slope and different y-intercepts. I'm right here. Parallel lines have the same slope and different y-intercepts. So if we're looking at something in slope-intercept form, or for that matter, in point slope form, because that the m slope is evident there too, we can tell if things are parallel or not by comparing their slopes. And it, technically, so that it's not the same line, they have to have different y-intercepts too. So I included that little tag there at the end as well. Okay, now different perpendicular lines have opposite reciprocal slopes. Let me give you an example. If one line has a slope of 1/2, a line that's perpendicular to it will be -2. Okay, if one line has a slope of 6, the other line that's perpendicular to it will have a slope of -1/6. Opposite meaning change the sign. It's two things: opposite, reciprocal. Change the sign is the opposite. Reciprocal means flip the fraction. Okay. That's perpendicular lines. I don't like the word perpendicular, how long it is. So if I have to use it again, I'm going to use this symbol right here for perpendicular. Okay. That takes us to this this example that says find the equation of a line parallel to y equals -2x plus 3 that contains the point 1,6. Now think about which form this is most conducive to. Which of the three forms of lines? Is it point-slope form? Is it slope-intercept form? Or is it standard form? Well, it would be point-slope form because we can pick the slope right out of this equation, and they've already given us a point. So we can plug that right into y minus y1 equals m parenthesis x minus x1, right? The 6 went in for the y1, the 1 went in for the x1, the slope that was in the other equation, since they're parallel, that's the same, is -2 right here, okay? Similar example, but using the word perpendicular. Write an equation of a line that passes through 5, -3, and is perpendicular to y equals 4x plus 1, and then graph both lines. I'll just show you what the graph looks like, but let's go ahead and do the same thing. Again, you can pick out the 4, and we're going to plug this into point-slope form. Remember, point-slope form is this. This 5 is an x, it's going right here for x1. This -3 is a y, it's going here. This slope on its way over to going into m is going to have a metamorphosis, and it's going to become -1/4 because we're talking perpendicular, right? Opposite reciprocal. So what do we have? Y minus -3 equals -1/4 x minus 5 would be perpendicular. They sure did it a different way there. I just want to show you the graph, though. The graph of this, the line they gave us is this one. The graph of the line that we came up with is this one. Do those look perpendicular? That look like a right angle there? Okay, that's kind of proof that what we're doing is correct, that whole opposite reciprocal thing. All right, one last thing. Vertical and horizontal lines. Vertical lines are always of the form x equals a number. Okay, I think if you look in your book, it might say like x equals h, where h is some number. And horizontal lines are always of the form y equals some number. I think that might, again, the book might say y equals k, just to pick a different value to stand in for that number. They're always of the form x equals a number and y equals a number. Why is that? Well, it really goes back to standard form, right? This is in standard form. This is like saying 1x plus 0y. Let's do it this way. Sorry. Take two. No, I'm doing all this in one take, so you just heard that error. X equals -1 is what this would be. The number, if we're going by ones, of course, 1, 2, 3, this is -1. This would be the line x equals -1. And what I'm saying is that this is in standard form. It's like saying 1x plus 0y equals -1. Okay? So it's vertical. Let y be anything. It's not that y just doesn't exist. It's that all of the y's can be whatever they want. The x value is still 1 on this line. Here's the point -1, 1. Here's the point -1, 2. Here's the point -1, -2. Here's the point -1, 0. The key characteristic there, the common characteristic, is that their x values are all -1. Okay, so think about this for a second. What do you think the equation of this line would be? If you said y equals 2, you would be right, because all horizontal lines are of the form y equals a number, and that number in blue here is 2. Again, if our scale is going by ones. I didn't put a scale, so let's just assume we're going by ones. So that would be y equals 2. Why is that? Well, because you can let x be anything. The y value is 2. If x is -2, the y value is 2. If x is -1, the y value is 2. If x is positive 1/2, the y value is 2. The key characteristic is y equals 2. Okay? That's all. Thanks for watching.